Okay, welcome back. Hope everyone had a good Easter break. So we're into Semester 2, Lecture 9. For the past 2 weeks we've been looking at some theoretical stuff. So 2 weeks ago we looked at NoSQL databases, and last week we looked at architectures for scalability and resilience. Two topics that it's well worth going over and reviewing because they might be important towards the end of the year. This week I want to do something more practical again though, so we're going to look at authentication and security in web applications. By the end of the week it'd be good if you could describe the basic methods of securing an application. So we're going to look at different ways of categorizing the authentication methods and how you might choose to use different ones in different circumstances. In order to do that you've got to understand what the different methods are obviously and what's different about them. In order to do that you need to have a grasp of the basic workings of web-based security, so you need to understand what's going on, under the hood to some degree. This week's going to be primarily tutorial based though, so having gone over the sort of important points, we're going to dive into you guys implementing something that demonstrates these different kinds of authentication. What I'm going to do is I'm going to split the screencasts up into 3 parts probably. So I'm going to do a screencast just going over the slides here because I've only got 15, and then I'm going to do another screencast that has the meat of setting up authentication in the application we're going to create in it, and then there'll be an extra screencast which is some of the high-end stuff looking at different methods of authentication like the Facebook authentication. So that's my plan for the week. Although we're talking about authentication, we need to think a little bit about identity. So all these things ultimately are about identity. How do you prove who you are and that you're not somebody trying to pretend to be you? And this draws in aspects of privacy and identity management in essence. So although we're primarily concerned here with the mechanism by which users authenticate themselves and identify themselves, we need to think about all these issues around identity, like how do you manage how far your information goes and who can see it. Presence is a more recent issue. So if you think about presence both physically and virtually, the fact that you were in a pub at 2 o'clock this morning when you had a lecture at 9 o'clock is possibly something you want to keep to yourself. So this is a privacy issue again. Presence, the idea that I can be present physically somewhere, so an application like Foursquare might track that, or that I can be there virtually. So for example, I'm logged into ShoeSpace currently and I'm looking at a particular assignment and there are other people in the same group as me working on that assignment. Do I want the fact that I'm logged into that system at that time to show up to those users so they can chat to me about what's going on? All these sort of features and issues revolve around the idea of you identifying yourself to a system and being present at a particular point in time. So again, although we're primarily concerned here with the mechanics of logging into something, think about all these issues around authentication, specifically the privacy ones and the presence ones. Most applications need to establish a user identity, so that these two primary things, that you are who you say you are and you're not somebody trying to pretend or to fake being someone else, and that you're allowed to do the operation that you're trying to perform. Around this there's this personalization issue. So if you look at applications like Google Mail, I can change the look and feel, I can change the what widgets are displayed on the screen, I can change the order of the information. So this idea of personalization, so I'm identifying myself to an application so that it can use my profile to cater the application to my needs, are quite important. So this idea of personalization is also linked to identity and proving that you are who you say you are. We're talking about the mechanics here of logging into an application purely at the level of your browser interacting with a server. Underneath that there's the protocol that's being used, so HTTP or HTTPS. Towards the end of these slides I've got an implications slide where we talk about the outcome of what we're about to discuss. please bear in mind that if we're using HTTP URLs, everything that goes between the client and the server is transmitted in plain text, which means usernames, passwords, cookies, everything else is in clear text. Now ideally, when we do the practical part, we'd set up HTTPS servers and we'd get a packet sniffer and we'd look at the traffic and we'd look at open traffic using HTTP, and you'd be able to sniff people's passwords, versus HTTPS where you wouldn't be able to see the traffic that's going backwards and forwards. Configuring a HTTPS site involves a lot of administration that isn't particularly technical, specifically proving your identity to a certificate authority so that they can then issue a certificate which can be used to generate the secure sockets connection. So it's not too technically involved, but administratively it's problematic to actually set up a HTTPS server. Towards the end of the year, if we have time, we might do some sort of locally signed server configuration. But the point I want to make here is everything we're talking about works equally well over HTTP or HTTPS, but if you run your website over HTTP, all the usernames, passwords and cookies, and all the other information for that matter, will be transmitted in clear text and will be able to be intercepted by anyone. So, for production sites that you're logging into, HTTPS is a must, really. You don't want to be running sites over HTTP where people are logging into them. For public information sites, HTTP is perfect. For brochure sites, HTTP is perfect. But where people are putting personal details in, and personal details are being transmitted over the wire, whether they are visible to the user or to all users, really you need HTTPS. But that's not something that's going to be the focus of this lectures. This is more about the mechanics of logging in. When it comes to classifying methods of authentication, there are a few different dimensions that we could choose. So we could say, what's the user experience, if you like, of the login? And there's an old form. The original form is called HTTP Basic Authentication, and this is where you ask the server for a page which the server knows is secured. So the server responds using the HTTP protocol, and it issues what's called an authentication challenge, which goes back to the client. So client sends a HTTP GET, server responds with a basic authentication challenge. The browser will then pop up a login dialog for the user, or whatever the user agent is, then enters username and password. That's sent back to the server. The server will then decide whether or not it wants to complete the original request and send a page, which would be a HTTP 200 response with the content, or a HTTP 401 unauthorized saying, I'm sorry, I don't know who you are. At which point the user interface might pop up the username and password dialog again because it's been retyped, or take any number of other actions. In the practical part of this week, we're going to create an application to look at these different kinds of authentication, and here's the app that I've been working on locally, and this application has two parts to it. We have an API which, for reasons we'll come to, is controlled by basic authentication. So when I click this link, which I can't point to obviously in the recording, but is http ://localhost:/8080/auth-test/auth-test-API/index. Click on this link, it goes to the server that says, oh, this is a secured resource, which will then respond with a basic authentication challenge. My browser will pop up a dialog asking for a username and password. I'll type in a username and password, and then depending on what I type in, I'll either get the page or I'll get an error response. So if I click on this link, you'll see this dialog pops up. So you might have seen this before when connecting to sites. Pardon me. And I've set up an admin username and password, but I'm not going to do that right now. I'm going to just type in some nonsense, click login, and it prompts the dialog again because it's failed to log in, and that's the extent of the user experience for a failed login, which is not particularly good. If I do admin, then I get redirected to the original page, which is just a page that says API, because actually this is a JSON service under the hood. If I go back, I haven't tried this before actually. I'll try the logout controller. Should be. I think that might have logged me out now. Let's have a look. Test API. No, it hasn't. Okay. So what I'm going to do is I'm going to close that window down, and I'm going to create a new incognito window. Localhost auth test. Okay, so that was basic authentication. The next step up from that, if you like, is form-based authentication, and this is where we request a URL from the server. The server says, oh, this is a secured resource, and the server then redirects us to a page, which is a proper web page, beautifully crafted HTML with a login form in it. We fill out the login form, send it back to the server. The server then decides if that's acceptable credentials, and if it is, redirects us to the original page we were going to go to. Now, if my logout worked okay, here I've got a secret controller, and this should be controlled by form-based authentication. So when I click on this link, which is /auth-test/secret/index, I send this URL to the server. The server says, oh, this is a secured resource, but it's controlled by a form. So it then renders HTML, so it sends the HTML for a login form back to the client. I fill out the login form, which is sent back to the server. The server will then do a redirect back to the original resource. Okay, so I'll click on the link, and here's my login form. So you can see this is actually a step up in terms of user experience. We've actually got something that we can craft now and change so that it's in line with our application. I go admin, click the login button. So this sends this form back to the server, which will then, if I've entered the right credentials, redirect me back to the page I was trying to go to originally. Okay, and that's this page, secret list. So that's form-based authentication, and you can see it's kind of a step up in terms of usability and getting things to look as we want them in our application. Those are the two most common ways of authenticating, and usually form-based authentication is what you get with web applications. However, there are two others. So what I've chosen to call delegated authentication here. So this is authenticating using third-party services like Google and Facebook and Twitter. There are some protocols around this. So OpenID is one, and there's another protocol called s2l9, which we'll briefly take a quick look at, which is what's used in the university. So if I go to flickr.com, I click the sign in, and what's happened is Flickr's chosen to pop up a new window with their login form. So this is a form-based authentication with a little extra twist in it, if you like. But the HTML form that it sent me back has got a button to create a new account. It's got two links that say you can sign in with Facebook or Google, or you can sign in with your Yahoo credentials. So depending on what I click, I'm starting to get lots of choices about how to log in. So this might be considered to be delegated authentication. So I could obviously choose to log in with Facebook or choose to log in with Google. Alternatively, this is a website that I'm involved with, and we can use this to demonstrate a particular principle. When I go to log into this service, which is KB+, I click on the login button, and I'm redirected to, so this is something called s2l9, which is an internet standard for doing distributed authentication. And this is something called the UK Federated Access Management Framework. So it's asking me which organisation I'm a member of. So obviously I'm a member of Sheffield Hallam, and I log in there. This application is actually hosted by EDINA, so the University of Edinburgh, and I've typed in Sheffield Hallam and it's come back and said maybe Sheffield Hallam University, so that's us. When I click on that link, I get sent back to a s2l page, which is, you might notice this from whenever you logged into s2space. This is the actual page which Sheffield Hallam University, as an identity provider, uses to allow its members to sign into that service. So this is the standard Hallam login, which can be used to authenticate against almost anything. So you could write an application next year and deploy it on some cloud infrastructure, and provided you'd okayed this with the university, you could use the university's login service, which means that any student could log in using their credentials, which is kind of handy. So I put in my my Hallam credentials. There we go. So I'm looking at a s2l page here, right? I click login. Hallam then authenticates me and redirects me back to the page I was going to originally, which is back to KB+. So what this means is that anybody from any UK university can log on to this web service. This web service doesn't need to have a list of users ahead of time for who can log into it, and somebody could be added to King's College London, for example, and they would be able to log on to this service in Edinburgh tomorrow, even though the service in Edinburgh didn't know anything about them previously. And the way that this works is that all UK universities have what's called a trust infrastructure between them, and as long as Edinburgh's service trusts whoever you're trying to log in with, so that would be King's in this example. If King's College says yes, this is actually a legitimate valid King's College user, then this service at Edinburgh will trust that information and create an account for that user to log in with. So this is distributed authentication, and it's quite useful. So that was delegated authentication. So we're using a third service to try and connect to something. And then a fourth one might be API keys, which were in vogue a few years ago but are less common now. And this is the idea that I can say ampersand API key on the end of my request, and it's a shared secret between a caller and a callee. Very easy to break, very easy to intercept, and not particularly secure, but really easy to use. Quite good for user tracking when you're more bothered about figuring out who's making the request than actually authenticating them. So just identifying the caller. Things like Google Maps API still use an API key for this very reason, just so they can track how many requests you're making and do some kind of rate limiting. So API key is a user experience for developers, really. It's not particularly secure, but it is there. There are some variations on basic authentication. The first one we looked at there, where rather than sending usernames and passwords, you can send biometric information. So you can use novel devices like retina scanners, thumbprint scanners, and certificates as well, so exchanging digital certificate information. So these are the four basic methods in terms of the user experience, and really there are some diagrams here that just talk through the things that I've just talked through. So basic authentication, the user requests a protected resource. Assuming that the server doesn't already know who the user is, they send back a HTTP basic authentication challenge. The user sends their username and passwords, and depending on the result, if it was okay or not, you'll get a HTTP 200 with the actual page, or a HTTP 401 with an unauthorized response. So that's the diagram, if you like, of basic authentication. HTTP form information, form authentication, very similar. You request a protected resource, but this time you get redirected to a login page. You submit the form. Assuming that it was okay, you get redirected to the source. If it was a failure, you get an error page back. So that's form-based authentication. And the third one, this kind of delegated authentication. Here's a diagram describing using Google as a login source. So the example I took you through earlier on was using Sheffield Hallam as an identity provider. This is essentially using Google as an identity provider. This example is actually for OpenID rather than for Shibboleth, but similar concepts are at work. You basically have a third party in the middle. I'll try and talk you through this, but there's obviously quite a lot going on. The user has said sign in, has done something which requires a sign in. The web application sends a challenge to the user who says, I'd like to sign in with Google. Some stuff goes on between the server and Google, but ultimately what happens is Google sends a page to the user saying, the user gets redirected to a Google page that says, please log in using your Google credentials. The user fills that, the go button goes to Google, which then authenticates the user. There's then a conversation behind the scenes between Google and the web application that allows the web application to then send the user the page they were after originally. It all relies on lots of redirects, and it's quite complex to get working. Once it is working, obviously it's quite clever because you don't need to have big tables of users in your local database, and as long as somebody's got a valid Google logon, then you can use their credentials. Same is true for Facebook. The really useful thing about Google and Facebook login is that those organizations take proving that the user is who they say they are very seriously, and they take the task of taking down users who aren't legitimate very seriously. So if you have form or local authentication, and you have a registration page that users can log into. I could say that I'm Frida Smith, a young lady from Edinburgh, and the credentials that I put into a registration form, it's very difficult to prove that, right? The service has no way of knowing that I've just completely faked somebody else's identity, and until I get found out, which is going to be quite hard, those credentials can live in a local database, unproven. Making use of services like Google and Facebook are quite good because obviously my Facebook profile has my friends attached to it. If you see a Facebook profile with no friends attached to it, you've got to start asking yourself how real that is. But if you see a Facebook profile that's got lots of friends with real activity going on, then you might think, actually, this looks like a valid Facebook account. Facebook accounts get taken down very quickly when Facebook realise that they aren't legitimate. So there is some level of trust involved in using those services for authentication. Obviously, you have a Sheffield Hallam login by virtue of the fact you're on a course. I mean, that's quite a serious statement of authenticity, and that you are who you say you are when you log on using a Hallam ID. So this idea of using a third-party source for authentication is becoming very, very popular because it means you've got some measure of certainty that the users who've registered really are who they say they are, and not just some fake identity that's been stolen. That's a slight digression away from the mechanics of authentication. So there we've looked at the three fundamental ways of authentication: HTTP basic, HTTP form, and then this kind of delegated authentication process. Just drawing up on that, another way you might classify the authentication is where the authentication data actually comes from. Is it local? Have I got a local registration form that says please enter your username and set a password and give me your email address? Or are we delegating that task out to some source like Facebook or Twitter or the UK Federated Access Management System, which would be UK universities? Have a think through the relative advantages of that. Obviously, setting up a local database where users register and they put a username in and a password, like the first time you signed up for Twitter or Facebook, that's what they were doing. There are some advantages because you're completely in control of that data. But the flip side of that is if you want to be able to integrate with these sources, if you want to be able to integrate with Google Plus pages or Facebook pages, maybe using those services to authenticate has some other advantages. So just mull over the relative advantages of having a local store of authentication data versus delegating that task to some other party. Another thing that we might do is to try and classify authentication mechanisms by need, and web services are a particularly interesting thing here. When your web service client makes a request of a web service, there's obviously no browser involved because it's a machine-to-machine communication rather than a user typing into a browser, which means that authentication methods that use redirects, specifically form-based authentication or delegated authentication, are very problematic because we can't write web service clients that understand the vagaries of all the different HTML forms that go backwards and forwards. And what that means is that for web services, HTTP basic authentication actually turns out to be a really good solution because the only thing that we can get back is an authentication challenge, and there are just two fields that we need to fill in going back the other way, which is some sort of principal or username and some sort of credentials or password. So if you need to secure web services, be they SOAP or RESTful web services, then actually HTTP basic is a really good way of securing services. Obviously, bear in mind HTTP, HTTPS, because if you secure web services using basic authentication over HTTP, then those credentials will be transmitted in clear text, which is not a good thing. If we need a glitzy user interface, then we want something like form-based authentication. And ultimately, you could think that the delegated authentication usually has some kind of form behind it, basically. So we've got some way of customizing the user experience. Having talked through the three mechanisms that you can challenge a user to respond with their password, in essence, what happens? So obviously, we don't want the user to be challenged again on the second visit to the site. So having authenticated OK, the server will also send back with that valid page a cookie. And a cookie is something that the browser sends with every request after that. And we use that cookie to identify the user session, and that means that users won't have to log in a second time, because when they come back with their second request, they'll pass back the cookie to us, and we'll say, okay, I recognize you from last time you were here. If cookies are transmitted in plain text, then they can be copied, and another user could use that cookie to pretend they are the user who's logged in, which is why we really don't want cookies sent over plain text connections. We'd like cookies sent over secure connections. What I might do is, if I just close these down here, I have a plugin installed, which is a cookie management plugin, and if I just reload this, I've just deleted all my cookies, so I'm clear. If I go back to our auth test application and I go to the secret controller, it'll challenge me to log in. I'll log in as admin, and let's just quickly here. When I've gone back and got my page, this page has sent me back a JSession ID. This session ID has been embedded in a cookie. With a bit of luck, EA0. Yeah. You'll see that this is actually the same as that. When I submit this login form, which I'll do now, the server has said, yep, that looks like a valid username and password, and sent me back this page with that cookie. And on the server, we now know that the session attached to that cookie is a valid logged in session, which means that when I go to new secret here, when I click this link, auth test secret create, the browser is also sending that cookie back to the server. The server says, oh, there's a cookie with this request. Oh, the session that cookie identifies is logged in, and therefore I don't need to issue a challenge request, and I'm going to go ahead and assume that the user who's logged into this is the admin user that we logged in with originally. So you can see that by having the cookie, we've basically avoided the fact that the user needs to log in twice. And what will happen is the server will expire this session ID after a certain amount of time, which is usually configured on the server. I think the default's about 30 minutes. Some servers set the session expiry to be infinite. This isn't a good thing, because if somebody sniffed your session ID, that means that they can indefinitely use that to pretend that they're you. So logging out of web services and thus invalidating your session on the server is a good thing, because it means even if somebody has got the cookie for that session, as soon as you log out, that cookie is no longer valid. So this is how we navigate around without being prompted again for a login, because we've got this cookie living in the browser. If I go to ShoeSpace, and if I log in, so I've logged in, and if I go back to my cookie management thing now, you can see that cookies are stored according to the domain that they came from, and when I was accessing this web application, I was accessing it using localhost 8080. So you can say this cookie is in the domain localhost, and this was the path auth test, and here's the name of the cookie, JSession ID. If I refresh this now, having just logged on to Shoe, you'll see I've got lots of other cookies floating around. So I've got some cookies from the Google domain here, and I've got some cookies from shoe.ag.uk, and I've got some cookies from shoespace.ag.uk, and I've got some cookies from students.shoe.ag.uk. You can see lots of JSession IDs, so this actually tells us behind the scenes that we know that ShoeSpace is actually implemented in Java, so we know that it's Blackboard system in essence. And some other information. So you can see that cookies can be used to store lots of information in the browser, which the application can then retrieve next time. We've discussed European cookie law, I think, last year. generally speaking, storing opaque things like JSession IDs in cookies is not particularly problematic. You don't want to use cookies to store private and personal information, though. So here, localhost, just a JSession ID. All these other sessions, we're storing lots of information on the client side. So, cookies are the mechanism by which this sort of authentication system operates. So here's the implication slide that I was talking about. If you're using HTTP, then usernames and passwords and cookies are sent in clear text. Anybody can intercept them, anybody can reuse them to spoof or pretend to be you, basically. Setting session timeouts is a good thing. Setting them quite low is a good thing, because it means that even if somebody has intercepted your cookie, they might not have got your username and password. They might have only sniffed a request since you logged in, but they can still use that cookie to pretend to be you. And as soon as you log out, the server will say, well, this cookie is no good anymore because the session it's attached to has been logged out. So physically logging out of services after you finish using them is quite a good idea as well, because it means if somebody has got your cookie, you're actually preventing them doing any real or any further damage with it, at least. If you're setting up login and authentication systems, you need to be using HTTPS. So we've looked primarily at three kinds of authentication. Local database with basic authentication. So this is where there's a table in our local database with usernames and passwords in. Basic authentication is using the HTTP basic challenge mechanism. So we use the protocol itself to say, oh, you've requested a secure resource. Could you please prove to me who you are? The second one would be the similar setup with the source of the authentication information, a local database with usernames and passwords, but form-based authentication. So when we access a secured resource, we get redirected to a pretty HTML form. We fill it out. If the details are correct, then we get redirected to the page we were going to originally. So this is very much appropriate for web applications. It's really form-based authentication, really not appropriate for web service authentication, because each web service would have to know about your particular HTML authentication page, and that's not an ideal situation to be in. So we don't use form-based authentication for web services. We only use basic authentication. And the third type is something like Facebook. So we're delegating the task of having a user database off to some third-party service, and that's really useful for web applications for the same reasons that form-based authentication isn't particularly good for web services. You generally wouldn't use remote databases for web services either. So you're going to find that accounts for web services are usually going to be defined locally somehow, whereas end-user accounts, you might want to think about using some remote database, particularly if you're concerned to prove that a user is who they say they are. Actually, that's a real challenge for applications, to prove that it really is Jane from Edinburgh rather than Ian from Sheffield. I might have just faked some credentials on a sign-up form. Delegating this task to someone like Facebook, actually, we're substantially increasing our tasks of detecting identity fraud, basically. That's not to say that that's going to protect you from identity fraud, but it's something to bear in mind, certainly. So the summary really, there are several variants to authentication, but most of them revolve around sending a cookie back to the browser, and then that cookie being resent to the server to identify a session. Some stateless methods are available where the session isn't stored and sent back to the server. Those were the API keys, which we don't use anymore. HTTP basic authentication can also be configured per request, so you never actually store the cookie that's sent back. It's just every request you're challenged and you're asked to provide the basic authentication. That's reasonably common as well. And the critical point really is we need to avoid sending private information over HTTP connections, and we want to use HTTPS. So that is the end of my slides, and we're going to be on now to going through the tutorial, which I'm going to try and split into a number of parts. So watch out for the next screencast, which will talk you through the first part of this. And any questions, stick them on the wiki, which will be a good thing to do, or just grab me in class. Okay, thank you.